So today, as I said, I'm going to talk about this topic called as inside story of concrete block industry. Now, everybody are aware of this product called as concrete block. Now, concrete block is one of the well-known product in construction industry. I think slides has to be. Slides are not working. Okay, now it's good. Okay. Okay. So, as I said, concrete blocks are one of the well-known products in the construction industry. Before I talk about the concrete block and the industry and the evolution of the industry, I would like to just throw a light on the history of the blocks. Now, everybody would be aware of this theory called as Charles Darwin's theory of evolution, which defines evolution as descent with modification, which means species change over the time, give rise to new species and share a common ancestor. So like the evolution of species, we also have evolution of these concrete products. Now, if you see the prehistoric man, what he used to do to cover the shelters. If you see during the good olden days, now the masons who does this block works, this all skills, if you see in the prehistoric days, the prehistoric man used to actually considered as the first mason, because he used to do the stacking of rocks in front of his home just to ward off animals, rains, wind and snow. And that is the way, that is the place where actually these concrete blocks started evolving. And the well-renowned structure, that is construction, that pyramid, Egyptian pyramid. After the construction of pyramids, we all know that actually the pyramids were actually done with the mud bricks. After the construction of the pyramids, actually there were a lot of attempts made, to make it into concrete forms. So after a lot of trials and errors, the first successful concrete block actually happened in the late 1700s. And this was actually made by mixing some powder like quicklime and moist sand together and molding into a usable building block. Now, when they were molding it, they used to use the available resources like the stones and the timbers which were available to make the molds. So when the first block was introduced in the late 1700s, it was only used as a shelter or a barrier, as I said. Now, in the late or in the earlier 19th century or the 20th century, the industry started, we can actually say. The reason is because in 1904, Mr. Herman and Jesse Besser patented the first hand-tap concrete block machine, which actually produced one block at a time. So this idea actually caught on and the use of block grew. And in today's time, you can see the block industry where people having different levels of automation machines being used for manufacturing of concrete blocks. And over the last 100 years, if you see, the uses of concrete blocks have greatly expanded along with the technology to produce them. Now, if we see about with the time period from 1700, in the late 1700 to 1900, we can actually presume that a lot of actually development had taken place to come into a mechanized production. Now, going with a manual production by using the available resource and then converting it into a mechanized production with a hand tap concrete block machine was a long journey. That actually made the beginning of the industry. Now, as I said, with the machine, with the hand tap machine started by Mr. Besser, the industry started. But initially, the blocks which people used to produce was only the solid blocks, because people always went for a solid component, since block was a replacement or an elevated form of brick, you can say. So brick was available from long time. People wanted to get into a better product where it can be of more use to the end user. So with blocks, the first product which came into existence with the blocks was the solid blocks. Now we have different types of concrete blocks in today's time. Solid blocks, which is widely used, hollow blocks, AC blocks, thermal insulated blocks. Now AC blocks, I will not be not throwing much light on it, as we had one session on that, and thanks to Mukund Joshi sir for sharing their experiences and knowledge on AC blocks. So there's solid blocks and hollow blocks and thermal insulated blocks. Now, what is a solid block? A solid blocks is basically a block made with the standard dimensions. In today's time, what we actually produce is of a standard dimension with a thickness of 200 mm, 150 mm and 100 mm, which we normally call it as 4-inch thick, 6-inch thick and 8-inch thick. And normally this 6-inch thick and 8-inch thick are used in the external walls, and 4-inch thick are used in the internal walls. Now, when we talk about the hollow blocks, now hollow blocks has been in the market for quite a long time. Although the first hollow block was introduced in the earlier 1900s, the acceptability of the hollow blocks is still not to an extent where it had to be. Now, there are a couple of reasons why it was not that successful in Indian market, whereas if you see in the global market, and people have accepted the fact and the advantages and the usage of these blocks in a well way. Now, talking about the technical specifications of these blocks, we have a Bureau of Indian Standard, that is Indian Standard 2185 Part 1 2005, where it actually talks about the total, talks about the specifications of the product, like the dimension tolerance, the limitations on the dimension tolerance, the height, based on the mechanized production. Now, today, as I said, we are talking about the inside story of the block industry. Everybody would be knowing about the technical specification of the blocks, but this dimension tolerances today, whatever we are talking, or the water absorption and any technical parameter for that matter, it all arrived based on the experience of our early ancestors who were part of the industry and who were also actually have contributed to the evolution of this industry. Now, if we talk about the blocks, now the blocks manufacturing with the starting level with a handmade machine to an automized machine. The blocks which are produced with the handmade machines and the blocks which is being made from with the automated machine, we find a lot of differences in the technical specifications, and also if you see the physical properties of the product also, we might come across with a lot of differences. How do we actually arrive, or how do we conclude that a product is a good product or it's a quality product? So to certify a product is good or bad, we actually follow the guidelines as per the Bureau of Indian Standard, where they have actually arrived at certain parameters, which I'll be actually sharing with you today. So with the specification of the concrete blocks, as we see, any block being produced, we should always have a tolerance limit of actually the length being plus or minus 5 mm, the width and the height being plus or minus 3 mm. Now this parameter is being considered because at the application this matters a lot. Now coming to the point where we talk about water absorption. What happens if the water absorptions are too high? We talk about water absorption having less than 10%. Now, as I said, in my experience, I've seen blocks where we have been doing production of blocks where the water absorption is less than 5%, which is almost 50% than the specifications what they've given. But as I said, now the 10% arrived because we always consider that the product being manufactured starting from the base level, that is with handmade. So in any case, even with the handmade blocks which is being produced, should not be having the blocks water absorption more than 10%. And then the drying shrinkage less than 0.06%, moisture movement 0.09%. Then coming to the block density. What is this density? Now, density plays a vital role in the construction because the higher the density, the dead load is more. So the loads acting on the structure becomes more heavier. So considering the structural part, the density of the blocks were divided or defined with the grades. If you see with the grades in hollow blocks, now again with hollow blocks and solid blocks, we have the load bearing and the non-load bearing categories. So again with the kind of the load bearings and the non-load bearings, the grades has been defined. Now the hollow blocks having a density between 1100 to 1500 kg per cubic meter comes under the grade of B grade, and uh, uh, hollow blocks having a density about greater than 1500 comes under the category of A grade. Now when we talk about the density having greater than 1500 kg per cubic meter, so in this case what all the things has to be considered, or what is the right way of manufacturing the blocks to achieve such kind of a density, I'll be sharing you my experiences and also some literatures relevant to that going forward. Now coming to solid blocks. Now solid blocks are solid in nature, so the products which have been manufactured will always be denser than the hollow blocks. So the density of the solid blocks shall always be greater than 1800 kg per cubic meter. Now coming to compressive strength. Compressive strength, again, depending on the application, whether it is a load bearing or non-load bearing, the strength has been derived. That is, the non-load bearings will always start with a minimum of 4 Newton per mm square, that is 4 MPa, 5 MPa. Then with the load bearings having starting with minimum of 7 MPa to 15 MPa. Now, as you have seen in my first slide, one is the solid hollow blocks, then we have the thermal insulated blocks. Now solid and hollow is one which many of the people would have seen in the Indian market as well. Thermal insulated blocks are a special product. Now apart from this, in today's time we also have a new innovative product which we also call it as interlocking blocks, concrete interlocking blocks. Although the application is very limited in our country, still I would like to share you the details of this particular product which is picking up slowly in our country. Now this thermal insulated blocks. Now, thermal insulated blocks, the idea of starting with thermal insulated blocks was to have a better thermal properties and also acoustics. With this thermal insulated blocks, as you can see in this particular image, basically it is a combination of solid and hollow together with an insulation material in between. Now, what is this insulation material? Most of the time, if we see with the conventional practice of construction, I mean, we used to have two walls having a gap in between, or we used to have two concrete walls integrated with a insulation material called as styrofoam, basically a polystyrene material. Now, with the idea of the conventional practice of construction, thermal insulated blocks was introduced. This happens with a mechanized production where we have the consistency in terms of dimension with the mix as well as the strength of the property. Now, as I shared with you all with the technical specification of the concrete block, which major of the manufacturers might be knowing about the technical specifications and the procedure to produce it, but how do we actually achieve the right quality product to ensure that we actually are in line with the requirement of the Indian standards or with the customer's requirement? To do so, I would actually like to share a few things on this particular thing. Is any manufacturer in this industry who produces concrete blocks have to focus on 3M. When I say 3M, it's about material, machine, and manpower. Now, having the right material for the right machine along with the right manpower gives the right product. Coming to the material part now, the common material which is being used for producing blocks, cement, SCM, which we call it as supplementary cementitious material, aggregates, additives, or admixtures. Now, as most of them would have experienced that cement, we have range of cements. Again, when we talk about cementitious material, we have variety of cementitious material. Aggregates, we have different sizes of aggregates. Additives or admixtures, we have various range of admixtures. Now, normal cement which is being used for the production of concrete blocks are the ordinary Portland cement. Now, coming to the cementitious material. Now, most of the manufacturers in our industry are actually not aware of the fact that with the addition of cementitious material and with the right proportion and the quantity and the right material of additives and admixtures, we can actually produce a very well product with good cost optimization without compromising the quality. To talk on further on this particular topic, I would like to share you few materials which by my experience we have achieved good results. Now, when we talk about a concrete block, see, for example, when you're talking about a manufacturing of a solid blocks, we always look for a solid mass having higher density in it, and also we think about getting higher strengths without understanding the fact that just by addition of more cement, the higher strengths achieving is not the right way of getting the mix. Now, higher the cement, the higher the carbon emission. Sorry. So today we have supplementary cementitious material in our industry where we find very easily available, such as fly ash. Fly ash are basically the byproducts of thermal plant. We have GGPS, which is a byproduct of steel plant. And apart from that, we have many other products like silica fumes. And also, I would like to just talk about one particular product which which I have personally experienced, having a good cost optimization where we can reduce the cement content. As I said, the cement exhibits more of carbon. So in any of the construction today we are talking about green building concept, we are talking about LEED certification, GRIHA rating, eco-friendly products. To make the product more eco-friendly, the reduction of cement actually contributes the product, making it as more of an eco-friendly product. So when we talk about this particular supplementary cementitious product, there's one product which is also supplementary cementitious material called as iCrete, where we reduce the material, where we reduce the cement content to an extent where the carbon emissions drops down to a very good level. I shall be sharing some facts of and figures of the product and the results based on the trials and also with the continuous productions what we have done in the past. Now going forward with the aggregates. Now aggregates, when we talk about aggregates, most of the time we always think that the higher the size of the aggregates gives the better strength to the concrete or the concrete block. So it's actually basically, as I said, cement, cementitious material, aggregates, additives together. When you have a right composition, then you have a homogeneous mix. Now everybody should make a note of one fact, that in concrete block industry, the mix should not be richer by one volume of cement to 6 volume of aggregates, combined aggregates. It should not be richer than that. So to make a homogeneous mix, we should be aware of the fact that we make the mix in such a way that it is homogeneous and we have the right requirement to be met. Now, as discussed now with supplementary cementitious materials, now these are used as a reduction of cement which are normally used individually with Portland cement or blended cement or in different combinations. Now, what is the use of it? As I said, one, reducing cement itself is a big achievement, because today, it's a myth that most of the time we talk about the fact that the more the cement, the more the strength. But actually that's a myth. The fact is, it's not about increasing the cement. Having the right quantity of cementitious material in the mix to ensure that the concrete mixtures are economical, increase strength, and also influence other concrete properties. Now, once we have the material set, when we know that this would be the right composition to have the material, this would be the right composition to make the product. The second question arises is, how do we make it? What type of a machine would be the right machine to make this product a quality product? Now, machines, we have a lot of machines. We have a different level of machines, that is manual, semi-automated, fully automated. Now, whether the machine is manually operated or semi-automated or fully automated, the objective is to meet or to produce the right quality block or the right quality product. Now, in our industry, when we talk about the different level of machines, it also actually talks about the different quality of product being produced from that different level of machines. So the technology which is being used for different level or different types of machines are common. It is basically on the vibro compacted technology, and with hydraulic vibro compacted technology, we manufacture multiple products. Now, there are few machines in our industry where many manufacturer produces where they have limited themselves only for a particular product, and the machine is being customized in a similar way where only for the blocks it is being produced, and sometimes the other products cannot be produced. Now when we have these kinds of machines where we can have multiple products with the same machine, it gives an added advantage for a manufacturer. And as I said, with different level of machines, we also have a different level of automation. Now talking about the salient features of the technology with the highest level of automation, with hydraulic vibro compact technology to manufacture multiple products such as concrete blocks, concrete pavers, concrete curbstones and bricks, it's done in a large volume. And the batching is done with a fully programmed logical control technology where it is being weighed, batched, mixing and molded of products on pallets. Now once the product is done, the conventional practice of curing used to be water curing. Now here in this technology where most of the manufacturers in today have adapted with this vibro compacted technology of a high level of automation, we have a curing system where it allows the product to cure in the moisture, and we have a mechanized handling and shifting system which actually makes the reduction in damages of the product. Now I would be taking to you to a video which will explain you the working of this model. So as you all saw this video, as I said in the starting of the presentation, the theory of evolution. Similarly, the technology has also evolved. Now, right from the hand tap concrete block machine till the fully automated setup, along with the operation or along with the production system, we are also actually evolving with the technology of curing. With the conventional practice of water curing, today we are manufacturing products with a vapor curing system, or also called as hot air circulation system. Now what is this vapor curing system? Everybody would be knowing mostly with mist curing, membrane curing, water curing. Now vapor curing is actually a curing system where we have a rack system, hot air circulation system, where it is being cured with the moisture. Basically the vapors which are being produced actually makes the product to cure in the moisture. Now these curing chambers are built to account for the heat transfer to the concrete products by maintaining the required humidity, and vapor curing system accelerates the concrete hardening process. Now with this, the higher quality concrete through the controlled addition of heat and humidity is also achieved. Now, let me also take you through another video where the video shall explain you the process how this vapor curing system actually happens. Now, this video actually showed the process of vapor curing, where you could see the air being blown into the chambers, and with the air circulation happening there, and with the with the heat of hydration, the vapor being generated, and with the vapor actually the curing starts with curing in its moisture. Now with this technology, we have a lot of advantages. We are actually reducing the usage of natural resource, that is water, and the curing time is being reduced with this type of curing, where normally we do not have to actually wait for 28 days of curing to dispatch. And let me also actually tell you that with this kind of a technology, when we are producing the products, which most of the people in our industry have adapted in producing the blocks, the duration of actually with the construction also gets faster, because the earlier the supply, the faster is the construction. Now there are a lot of advantages with this technology. Now when we have this kind of automated technology, we have one, the homogeneous mix. As I said, when we have a proper mix design with a homogeneous mix, how do we know when the mix is homogeneous? If we have a proper batching system where the proper cement content or the aggregates or any material mixed for the production is being monitored properly, weighed and used properly, the homogeneous, and also we have this mixing time which has to be monitored properly. Well, most of the time at sites where we have a typical egg laying system, when what we say, which is being produced at the site, most of the time we tend to lose out on few things, is monitoring the mix, where we have the right quantity of material there or right quality of the material there with a proper proportion mixed into it to produce the product. Now, when we have this technology, we have the proper batching plant being installed with the proper monitoring system there, giving you the assured quality, and the dimensional accuracy of these products are always monitored in such a way that the precision of this is, as I said, the tolerance limit what we are talking about is plus or minus 3 mm or plus or minus 5 mm in terms of length, width or height. Here with this technology, we try to minimize as much as possible, and it's always restricted between plus or minus 1 mm or 2 mm. So with high dimensional accuracy, the application at the site becomes much easier, where the end user have the benefit of reducing his content of plasters or content of mortars for the application. And with this, we have a consistency of strength where the desired strengths are achieved. Now, the other advantage is, today we are talking about concrete block industry, where the concrete block industry have started with more products with the similar kind of technology. We used to call it as block plant, but today the block plant itself has variety of products being produced from the same plant. So with this, we have landscaping products called as pavers, we have external development products called as curb stones for the edge restraints. So multiple products can be actually produced with this kind of technology, where today most of the manufacturers in our industry are producing. Now also the advantage of this technology is, as I said, less curing period, with that short delivery cycles. Now I just took you all through the video of the process, the curing system, but the fact is also that everybody would not be in a position to go with the top level of automations for their manufacturing unit. It depends on their requirement, what kind of a requirement they'll be looking at, or what kind of a project they'll be delivering. So case to case scenario, it varies. So today in this topic of inside story of the concrete block industry, I would like to actually highlight on few factors that actually influence the selection of machines. Rather than actually looking at the level of automation, we should be initially looking at the production capacity. Whenever we are investing on the machines for producing the products, the concrete blocks, pavers or curb stones, what type of a production capacity are we looking at? And the kind of mobility, are we looking at a station machine, or are we looking for a mobile unit? Most of the cases in our construction industry, we require some machines where it has to be mobile, where it has to be shifted from one side to another based on the client's requirement. In such cases, high level of automation also can be done with that, but with certain limitations. And with some station machineries, we always have a high level of automations, and also at the mid level of automation, giving a better productivity. Now, apart from this, the most important parameter which matters for good quality product is the vibration and the compression efficiency. Now, it comes with the customization or with the level of machine size. Now, most of the time we talk about blocks being produced having various kinds of finishes, textures, difference in dimensions, or maybe difference in consistency of quality, I would say. So to have the right consistency of quality, we should be actually talking about the technical parameter of vibration or compression to understand whether it would be able to produce the right quality of block or not. And the most important part is the method of production. Now, what all this method of production involves? Our method of production, as I said earlier, it's about the mixing, the batching, the production, that is punching, casting, then the handling, curing. And again, once this, starting from the raw material, from the feeding of the raw material till the finished products, we should be having the right kind of methodology for the production. And with the right level of automation, we get the best product from the production. Now talking about the third M, which is manpower. Now with this technology of machines, what we are talking about, and with the right skill, irrespective of the fact whether we have the good machine as well as the right mix, if we don't have the right manpower for executing it, we still fail to produce the right good quality product. So when you talk about manpower, we require skilled people as well as unskilled people. When I say skilled people, need not have to be only technical people with the skills. It can be skilled on a non-technical level as well. And also we require unskilled level people to do to do some handling works where we might not require skilled people for that. And to handle the operation level and the efficiency, the vibration which I spoke earlier, To manage that, we need a technical and a non-technical people to manage the production. Now, with this 3 M's, material, manpower, and machines, we understand that when it is synchronized, we have the right product. Now, many a times it happens that you produce the right product, but still the clients are not happy with the execution there. We always come across many issues pertaining to the concrete blocks. We have the right mix being produced with the right materials being sourced out. We have the right machine there which is being used, where every parameters is being taken care of. We have the right people doing the right job there, but still after doing all those activity before the dispatch, also having our pre-delivery inspection, we assure that all the products whatever we manufacture are actually meeting the requirement of the client. But once we deliver at sites, we actually have come across many of the issues at site level which actually hampers the quality of the product. So basically, irrespective of the fact that we produce the right quality product, if it is being not handled in a proper way, we still actually face these quality issues at the site. So what are the common challenges what we face during the applications? Now, most of the times we see majorly it is handling or shifting. When we have the blocks being delivered to the sites, if we have a proper handling system there at place, the damage rate can be reduced. Now, the more the damage, more is the consumption of plasters or mortars for the end users when it comes to blocks. Because to cover up the damages at the corners or at the different levels of different size of the product, it has to be covered with mortar joints. And if there's undulations happening because of the covering of the mortars, then addition of plasters will be used to cover up the wall level. Now, because of handling, we might, or the end users might actually incur more losses because of the material consumption, extra additional material being consumed for plasters or mortars. Now, commonly found issues apart from handling is the conduit work. Now, at conduit work, most of the cases, particularly these are found with hollow blocks. I mean, hollow blocks, most of the time what happens is when somebody goes for a wall chasing work for the electrical conduit, it tends to crack out. Now, why does it crack? If a product being manufactured with the right mix, having the right web thickness. Now, what is this web thickness? Normally, when we have the hollow blocks being produced, that there we have the length portion having a thickness which we call it as a web thickness, and the horizontal portion having a thickness about 25 mm, which we call it as a shell thickness. So everything depends on the design of the hollow block and the thickness to take care of the load. And also we should ensure that the mix is homogeneous and is prepared in a proper way, in such a way that the characteristic of the blocks, hollow blocks being produced, meet the client's requirement. When there's a compromise in the quality, the shape of the hollow block seems well, but if the mix is not being homogeneous and properly compacted, then there are chances when there's a small crack or wall chasing work happening on the block tends to crack. But with the good quality product, when it's been produced, still because of the wrong application, again it tends to fail. So in such cases, to avoid more of damages for the block work, the advisable way of doing the electrical conduit work is through the cutters. Now, as you can see in this image, the way it is being, the wall chasing work has been done with the cutter machine, and then the conduit pipes have been placed, and then the work, and then it is being covered with mesh and then plaster work. So this avoids the damage and also actually helps the client, having a better finish with these kinds of products. The most important third part, which is the cutting. Now, when the products are being produced and being sent to client, we always have to cut certain blocks at the corners. Now, if the product, again, as I said, is not homogeneous or being produced with a proper technical specification in terms of vibration and compaction being taken care in the manufacturing, it might turn out to be a very bad quality product. Now, the cutting of the corner can be easily cut with the machines if it is being produced with a homogeneous mix. So these three things can be actually educated, and also the awareness can be created at the site if the products are being produced in a proper way. Now, blocks. As we all know, the blocks are basically the replacement of the bricks. Now, what are the differences the blocks makes against the bricks? As the picture itself suggests, we have a lot of advantages of concrete blocks over the conventional bricks. Firstly, the less energy intensive manufacturing process, which makes it as an eco-friendly product. Now, when we have a technology where from the material feeding till the delivery of the product, it's been managed in such a way, with a mechanized way, with the reduction of your cement content, reducing the carbon footprint, getting the right material strength with the less water absorption, meeting all the technical criterias of the blocks, makes the complete manufacturing process a very less energy intensive, so which makes the product as eco-friendly product. And in this production of the concrete blocks, when we use recycled contents, as I said about the supplementary cementitious materials like GGBS, from GGBS, fly ash, silica fumes, it actually helps in reducing the carbon footprints, which also actually gives us added advantage in terms of green building. And since these products are actually procured products, it saves water during the construction. Now, when we have a high dimensional accuracy with larger size of the block, it's quite natural that there shall be reduction in plastering and joining cost, which is very difficult to achieve in bricks because the joints will be more. So with that, the plastering and joinery cost also increases. Now, when we have a bigger volume, the construction cost in terms of the labor also actually reduces because it becomes faster and easier. Now, when we talk about a hollow block, it is lighter in weight when compared to bricks. So it reduces the dead load, wherein it also indirectly or directly reduces the reinforcement requirement as well. And with this, the high strength leads to minimum breakage or wastage during the transportation. So these are the common advantages what we actually see against the bricks. Now, going to the future, now what we see today is the construction industry is booming. We see a lot of construction activities happening. We see the construction is growing. So as the construction industry is growing, the concrete block industry is also growing. It is expecting business to be more stronger. And as the block industry expands and becomes more sophisticated, the block plants are also being forced to change to keep up the expectation actually. So the equipment manufacturers are also changing to meet the needs of the industry. And as it has for past 1,000 years, the block industry will continue to grow and change. Now, it evolved out of necessity for protecting human life. As I said in the initial slide of my presentation, the blocks started as a protection for the human life. Now it evolved with that necessity for protecting the human life. Today, many centuries later, also concrete block is still protecting people's life by providing safety, comfort, and shelter. So with this slide, I would like to conclude saying that the concrete industry's evolution started with just as a barrier for a human's requirement for a safety, and today with the technology, with the materials, and with the manpower, the industry has grown up to a elevated height, and we expect it to grow more higher in terms of technology and producing new innovative products, which I also actually touched on few topics such as the interlocking blocks, on interlocking concrete blocks for the building products, and many more to come in the coming days. So with this, I would like to end up this presentation of mine. Thank you.
Thank you so much, sir, for sharing your valuable thoughts and knowledge. Now, let us move to the question answer session, and I'll read out 4 to 5 questions and you can answer them, sir.
Sure.
So here goes the first question. That is how to make low weight concrete blocks, and that was asked by Mr. Mohan Kumar.
All right, that's a good question. See, in today's time, there's already a technology which is available in the market, which many of the manufacturers are aware of, and we also had a session on this, which is called as AAC blocks. That is one, but that is a different technology when compared to the technology I spoke today, or what I'm talking about today. Now, talking about the lightweight concrete, which Mr. Mohan is talking about. The lightweight can be achieved with the right composition of the materials which shall be used. Now, to make it lighter, you can actually go with cement, fly ash, and can reduce the sand content with recycled aggregates like the pond ash, which is available. But you have to restrict it to an extent about 20% of the content of the sand, because that is the restrictions from the BIS also, because the more and more finer content happens, you'll be having high water absorption in it. So with the reduction of density with the low denser products, you can still produce low density blocks, and many of the manufacturers are still producing today low density blocks with that. So in this, the coarse aggregate content will be very minimum. We need to do a lot of trial and error to achieve the right strength required. Without compromising the quality, we can achieve low density blocks with the set, as I said, with the raw materials like cement, fly ash. In fly ash, again we have class A fly ash, class C fly ash, and also you can use cement reducing agents, like I said about a product called as QCrete, where you can use that, and with a combination with this, with admixtures, you can achieve a very good product with a low density of concrete block.
Thank you so much, sir. Next, we have a question asked by Mr. Radhakrishnan, and the question is, cement plastering over AAC blocks, we find it difficult in adherence as it is smooth surface. Kindly advise on the same.
Okay, that's an interesting one actually. Now, see, AC blocks has a fine surface, no doubt. Now, when we do a concrete is always called as anti-skid finish. The reason is because if you have little coarser finish, the binding between the plasters and the concrete will and the concrete block will be much stronger. Now, many a times I can understand their concern, as asked by Mr. Radhakrishna, that they would find difficulty in plastering with blocks, because most of the time the plastering with AAC blocks it becomes easier because of the smooth finish, where the cement consumption also will be less. But when we talk about the concrete blocks here, now cement having its cement plaster, the basic material used in the cement plasters are cement and sand. And now when we talk about the concrete block, it has the same material there. So when we have two compounds having the same material, the bonding is much stronger. Now when we talk about the difficulties what they are facing, it depends on the quality of the product being manufactured or being used. As I said in my earlier presentation here, if you have the right quality product, then you'll never face any kind of plastering issues if you have a proper dimension product having an even surface. Because most of the time when you don't take care of the machines properly, you tend to have a, bulging effect on the surface of the product. So that time it becomes difficult for the end users to do the plastering work, where they have to fill in more of, either they have to grind it or they have to cover up that bulging with additional plasters. So when you have the right quality of the mix here with the proper compaction, when you have an even surface with the anti-skid finish, your plastering will be much better and the consumption of the plaster will be much less. And also many a times, many cases I've seen where people also avoid plasters and directly apply putty over the concrete blocks. So we can achieve any kinds of finish with the concrete blocks. If required, a smooth finish required from the client, that still can be achieved with the regular concrete block as well.
Thank you so much, sir. Next, we have a question asked by Mr. Chandrasekhar, and the question is, do you think we can manufacture cellular or castellated beams made in the concrete in the future?
Sorry, can you please repeat the question for me?
Sure, sir. Do you think we can manufacture cellular beams made in concrete in the future?
Okay. Yeah. See, we already have a technology where people are actually making hollow core slabs. So I don't see any challenges why we cannot make this product. We not have to wait for the near future to come. This is already available in the world with this technology, and many of the manufacturers are also doing hollow core slab here in India. So going forward, this shall be adapted at every level of construction in India. So I think with that, Mr. Chandrasekhar will find a solution very early also.
Okay, thank you, sir. The next question is, what are the possibilities of lightweight interlocking blocks? And that was asked by Mr. Surendra Patel.
Possibilities of interlocking blocks.
Yes, sir. Yes, sir.
Okay. I just want to have a clarity in this. Is he talking about the interlocking building blocks or it is interlocking paver blocks?
Sir, he has just mentioned as lightweight interlocking blocks.
Okay. Now, most of the cases, the interlocking happens with the tongue and groove joints, and all the manufacturing process in today's time with the interlocking mechanism, whatever we produce is basically the tongue and groove joints. So now with this, to make it as a lighter one, again, as I said to Mr. Mohan with the first question, it's all about with the mix and also with the kind of compaction and vibration you have with your machines. Now what happens is, when you have a lighter weight of product to be produced, you should be actually having the right vibration and compaction combination also, to ensure that there is no further cracks coming out after curing. So when you have both these combinations together, you can produce the same block in interlocking mechanism as well. Because with producing interlocking blocks is nothing but having the molds of that size, and to ensure that your procedure of or the methodology of your production actually meets that requirement. So whether it is a light density block or light density or a low density interlocking blocks, the methodology of production will be the same. It's only about the mix and the kind of operation methodology what you adapt. So it is achievable.
Thank you, sir. Next, we have a question asked by Mr. Shibin Panikar. And the question
Okay.
is, how future to make blocks from recycled materials?
Okay. For this also, as I answered in my previous question also, the India itself has gone to an advanced level where people are hardly using cement and majorly using recycled content. When we talk about recycled content here, we are talking about fly ash, which is basically a byproduct of thermal plant or a charcoal. We have GGPS, which is a byproduct of steel. We have silica fumes. There are many products where fly ash, GGBS and products which I mentioned earlier also called as iCrete actually have made the cement reduction, and these products actually help us in also ensuring that the technical specifications such as the strength, the water absorption, the cracking, everything are taken care of. So with this, over the coming days, I think we might actually also have a replacement of cement with such kind of products where the whole product can be done with the complete recycled content only. The only reason why we can't replace 100% of cement is because of the silicates or the calcium. So with that, over a period of time, I mean, a lot of R&D has been going on, wherein we are talking about replacing the OPC with PPC, which is already happening there, and now going with the green cement with the recycled aggregates, sorry, or a recycled product. So with this, in the coming days, it is definitely going to happen. But to his question, I would say now already we are at the stage where we are already actually reducing the maximum level of cement content with these recycled aggregates, and we are producing it. So maybe the further details, if he requires, can be shared offline to him.
Thank you, sir. Next question is, what is iCrete material? And that was asked by Mr. Vinay Kumar S.
Okay. Now, iCrete is a cement reducing agent. Now, with this, actually, you can reduce the cement and you can increase your cementitious material along with the admix. This helps you in reducing your carbon footprints and also helps you in achieving the strength at a lesser stage. Along with this, you can also actually reducing your curing period. But application of this depends from product to product. Hello.
Thank you, sir. Yeah, with this, we are ending our question answer session. So we have got a lot of questions, but since we have the time limitation, I'll combine all the questions and I'll send it to you, sir.
Sure.
Yes, sir. So we are done with the question session. Now, handing over to Anil Baliga, sir, for the vote of thanks.
Thank you so much, Ms. Anjali, for handling the very important part of the program, that is attending the queries and question and answer session. Now, we are in the fag end of this series, webinar series number 54. And it gives me immense pleasure to thank the guest speaker, engineer Ritesh Naik, who has agreed to be a part of this and address the on this topic. And wonderful explanation was given, and I think he has lots and lots of information. Probably due to the time constraint, I think he should be contacted in person, and we can get much more information in this regard. Thank you so much once again, Engineer Ritesh Naik for your sparing time with we all, and for the benefit of the our attendees and all for us. Thank you so much.
Thank you, sir. It's a privilege to have me for this particular event and for this session. And I'm actually I feel very good to be part of the ICI in association with QCrete to have this webinar to where I got an opportunity to share my experience. And with the limited time frame what I had, I hope that I could cover maximum I could do to reach the audience. And any queries pertaining to the sessions can always be addressed offline. So thank you very much again once again.
Okay, so thank you so much. And we cannot, as a part of Indian Concrete Institute Center Mangaluru chapter, we are very grateful and thankful to QCrete Readymix India Private Limited, with whose support we have been continuously conducting this webinar. And today we are on 54th part or the series. Would love to personally thank Mr. Kaushika, who's the person behind arranging this lecture, and also MD of QCrete Readymix, Engineer Shelly Fernandez, who's also one guiding spirit behind this this series, because he literally wants the dissipation of the information that people should learn both from the sources which is available just in front of them, and also from various other possibilities, but people should get the information. So this is his idea, and it is happening. And finally, Miss Anjali, who has wonderfully conducted this program. Thank you, Miss Anjali. And before concluding, would love to thank all the attendees, all the participants, members of our ICI Mangalore Center and other centers also, and the staff and management of the QCrete Readymix India Private Limited for all these opportunities. Thank you one and all. We'll meet you in one more session in the days to come. Thank you one and all. Thank you so much. Yeah. Good night.